All right, guys, I'm gonna record this video just because I didn't think about Mr. Nesbitt is going to be teaching our class on Monday. So we won't have a time to finish this lesson up. So I want to go ahead and finish it real quick via video. So please watch this sometime before before Monday. And then complete the homework that was originally assigned to you, which was page 277, 2 through 8 even. All right, so when we left class earlier today, we were figuring out how to graph tangent. So first of all, you're always going to start by using the x value of negative pi over 2. That's where your first vertical asymptote is going to be, and your second vertical asymptote is always going to be the period away from that one. So that's negative pi over 2 plus your period. So we found this asymptote to be at negative pi over 6. So we have 2 out of the 3 x values that we need. So we know we're going to do a little bit of editing to this, but we know that, let me get a pen going here. Well, it will let me write. We know that one of our x values is negative pi over 2. Sorry, I can't see what I'm doing here very well. Negative pi over 2, and then the second one, the third one actually, is negative pi over 6. But somewhere in between the 2 vertical asymptotes, there is also an x-intercept. Pretend like that's in the middle. There's also an x-intercept, so we need to know where that is located also. So the x-intercept is always going to be directly in between your 2 vertical asymptotes. So it's always going to be the same distance away from each one. Sometimes that will be easy to find. Sometimes that will be not so easy to find. So that's why I gave you guys the midpoint formula. So all this is a method for finding the middle. So if you take each of your x values and I have no idea where my mouse is. If you take each of your x values and add them together. All right, so common denominator would make this 3 out of 6. So if we take the 2 x values and we add them together, that would be negative 4 pi over 6. And then if we split that in half or multiply by a half, that's going to tell us where our x value is. So that would happen. Hold on, I'm going to pause this, and my mouse is not working correctly. Hold on one second. Okay, sorry, I couldn't get the pen to work. All right, so if we are looking for our x-intercept, it is going to be this value right here, halfway in between my 2 asymptotes. So I'm going to simplify this. I can take a 2 out of this and a 2 out of this. And I can take a 2 out of this and a 2 out of this. So this is negative pi over 3. So that's the location of our x-intercept. So we now know where our 3 x values are based on the period alone. So they are okay. We only need 3 little spots in our table for this one, since there's only 3 places, but our 3 values are negative pi over 2, negative pi over 3, and negative pi over 6. Those are our 3 x values for the tangent function based on the period. But then, if you look up at our equation, we also have a phase shift happening. So, let me get rid of all of this since we're done with that. So we have a phase shift as well. So the formula for phase shift is still c over b. So it's still going to be c is pi, b is 3, and then it's moving to the left. So what we want to do once we find our vertical asymptotes and our x-intercept, we are going to have to shift them pi over 3 to the left. So we are doing a lot of work with common denominators here, so sorry for the algebra, but if we want to move all of these pi over 3 to the left, then we're going to subtract pi over 3 from them. So pi over 2 minus pi over 3 sorry, negative pi over 2. These need a common denominator. All right, so this would be negative 3 over 6 minus 2 over 6. So that's going to give us negative 5 pi over 6. So that's going to be moving negative pi over 2 to the left. All right, this one's easy because they already have a common denominator. If we take negative pi over 3 and move it to the left, that's just going to be negative 2 pi over 3. And then our last one, if we take negative pi over 6 and move it to the left, this would need a common denominator. So negative pi over 6 minus 2 pi over 6 is negative 3 pi over 6, which is negative pi over 2. So once again, I suggest that you do the period change first and then do the phase shift if there is one, because that makes it a little bit easier. So once you do that, you are just about ready to put this onto the coordinate plane. So what I'm going to do from here is go ahead and label my x-axis. So everything over here is negative. So this is negative pi over 2, negative 2 pi over 3, and then negative 5 pi over 6. Now this is not really very well done to scale, but keep in mind that as long as you label your x-axis correctly, you don't have to do the scale very much. So there are vertical asymptotes on each x value to end x values. And we know that our graph is supposed to cross the x-axis in the middle. So the only thing that's going to change that is if we have any vertical shift. So if you notice, this tangent function is getting moved down 1 unit based on this minus 1 on the end. So all that means is that instead of our function going through the x-axis at negative 2 pi over 3, it's actually going to be down here at negative 1 at 2 pi over 3. So it's getting moved down 1 unit. So other than that, our tangent function looks normal. So there is one period of your tangent function. Now, y'all, this is a pretty extreme in difficulty as far as working with your fractions. Definitely not impossible, but keep in mind that your steps for this, and we'll look at another example as well in just a minute, but I'm going to show you guys how to work with cotangent as well. It's very similar. Oh, just kidding. We have another example. All right, so we're going to look at this example as well. I feel like for you guys, this is maybe on your last page where it says 3.3 practice. I don't have my sheet in front of me, so I can't guarantee that that's where it is, but I feel like it is around there somewhere is this example. So let's look at this one. So the first thing I'm going to do is I'm going to go ahead and identify the period and the phase shift. Those are the two things we really need to know to get our x values correct. So the period is pi over b. B is 2. So the period is pi over 2, so this one is half as wide as the normal tangent function. And the phase shift is still c over b, so dividing by 2 is the same thing as multiplying by a half. So this is going to be pi over 4, and I'm moving to the right. Okay, so we're going to use the period to do step 1, which is find the vertical asymptotes. So the first vertical asymptote is always going to be, for tangent, is always going to be negative pi over 2. And the second vertical asymptote is always going to be negative pi over 2 plus your period. So that is going to end up being 0. So these are my two vertical asymptotes. I find the x-intercept for my next step, so the point in between these two, by adding my vertical asymptotes together and dividing by 2. So negative pi over 2 divided by 2, we want to multiply by a half to get rid of that. So negative pi over 4 is where the tangent graph crosses the x-axis. So you now have 3 x values that you need. So that is without shifting. So that's just with a period change. And then we want to shift them if needed, if we have a phase shift. So, excuse my table. My 3 x values right now are negative pi over 2, then your intercept, negative pi over 4. and then 0. And I'm shifting all of these pi over 4 to the right. So I want to add pi over 4 to them. So if I add pi over 4 to pi over 2, negative pi over 2, this is 2 over 4. So that's going to give me negative 1/4. This one's easy. If I add pi over 4, I'm going to get 0. This one's easy. If I add pi over 4, I'm going to get pi over 4. So these are our new, our final x values. So there is a vertical asymptote at negative pi over 4, a vertical asymptote at pi over 4, and then my middle value, which is 0, is where the graph will cross the x-axis. So the last thing you want to check is if that 0 is moving up or down at all, and since there's no vertical transformations, you are ready to graph it. Excuse me for not being able to go through the 0. It's hard for me to do it with my little contraption I have here for recording videos. So we want to do the period change. That will give us the vertical asymptotes and the x-intercept, and then the phase shift will move it left and right if needed. This example does ask us to graph 2 periods, so if we needed to graph another one, we know that the distance between negative pi over 4 and positive pi over 4, so basically like each increment is going up by pi over 4. So like my next 0 is going to happen pi over 4 away from this. So that's going to happen at 2 pi over 4, which is the same thing as pi over 2. And my next vertical asymptote is going to happen pi over 4 away from that, which is 3 pi over 4. So if you have to graph another period, just use the increments that these are going up by. Once again, forgive me for not getting through the 0. And there is your cotangent function. So I hope you found that one on your notes. It's somewhere on there. So let's look at the cotangent function. So we're going to do this example as well, but we're going to graph 1 period for now. For cotangent, the first vertical asymptote is x equals 0. And the second vertical asymptote is just going to be that plus your period. So it's the same process as tangent, we just start in a different spot. The cotangent graph has its first asymptote at 0, not negative pi over 2. So for this function, let's go ahead and find the period, which is pi over b, and then the phase shift, which is c over b, and it's moving to the, oops, not to the right, it's moving to the left. Okay, so let's see, our first vertical asymptote is always going to be x equals 0. Our second vertical asymptote is always going to be that plus the period. So this one's definitely easier to find than the tangent. So this one's going to be pi over 2. So these are our 2 vertical asymptotes. The midpoint between these is still going to be where our graph crosses the x-axis. So you can find the midpoint by adding your vertical asymptotes and dividing by 2. So that's going to be pi over 4. So that is our x-intercept. So we have our 3 key points on the graph, and then we need to shift them pi over 2 to the left. So y'all know I love my table. You don't have to do one if you don't need one. But anytime I have a phase shift, I'm going to use a table. So my 3 x values are 0, pi over 4, and pi over 2. Please make sure that you put your x-intercept in between your 2 asymptotes. And then I want to move those pi over 2 to the left. So I want to subtract a half of pi from each one. So if I move this pi over 2 to the left, I'm going to get negative pi over 2. This one would give me negative pi over 4. And then this one would give me 0. So those are my new x values. So I know I'm going to use 0, negative pi over 4, and negative pi over 2. The outside x's are going to be your vertical asymptotes. The inside x is going to be where your graph potentially crosses the x-axis. So you want to check for vertical transformation. So this graph is getting moved down 1. So instead of it crossing the x-axis at negative pi over 4, it's going to be down 1. So it's going to intersect y equals negative 1 and the cotangent graph is upside down from the tangent, so it goes down instead of up. Okay, so same process, you just have to use 0 as your first vertical asymptote instead of negative pi over 2 as your first vertical asymptote. So we're going to look at one more example of that. All right, I think this one is on your sheet as well on the 3.3 practice section. If it's not, scratch one of those out and just look at this one. I think that one's there though. So let's look at how to do one period of this function. So first thing we want to do is identify the period and the phase shift. So the period is pi over b. B is just 1, so my period isn't changing, it's just pi. But my phase shift is c over b, so it's going to be pi, and I'm moving to the left. All right, so for a cotangent function, my first vertical asymptote is going to be 0. My second one is going to be the period away from that. So that's easy. That's pi. And my x-intercept is going to be directly in between my two vertical asymptotes. Okay, so my 3 points on the cotangent function are 0, pi over 2, and pi, so they're just like our parent ordered pairs, our parent x values, and then I want to shift all of these pi to the left, so that's going to be negative pi over 2, and 0. All right, so once we do that, we are ready to graph. All right, so we have negative pi over 2, and 0. So our vertical asymptotes are always on the outside, and then it's potentially going to cross the x-axis there at negative pi over 2. So there is no phase shift. There's nothing added or subtracted. Sorry, vertical shift. There's nothing added or subtracted, so it is going to intersect the x-axis. So the only question is, what does that 2 do to the graph? So like usually what a 2 does is it would take, so normally the cotangent looks something like this. What it's going to do is it's just going to stretch it out so it doesn't get quite as flat as fast. But since we are just so roughly sketching the graph, you are not going to see a very big difference in those. Like if you were to actually look at the graph of them, so like let's look at cotangent and 2 cotangent. There's 2 cotangent, there's 1 cotangent, so it's just like a tiny bit steeper, but by graphing by hand, we aren't going to be able to see that very much. So, you know, if you can, make it a little bit less flat than a normal cotangent, but like I said, you're not going to see it very much. And that should go through the x-axis right there, okay? So, I want you guys to now attempt your homework, which is page 277, 2 through 8 even. Even if all you, well, find the vertical asymptotes, find the x-intercepts. I think this is a decently straightforward process to follow. If you have any questions, feel free to ask me on Monday, okay?